Welcome everyone to the Land Tabor stream. It's good to have you tonight, Tuesday night. We're rocking on this week, getting things done. Getting ready for that CCIE 69 days ago. And hey, popping in to say hi, we'll make lunches for the little ones. Show IP, interface brief. Thank you for stopping in, my friend. Taking care of the fam. Appreciate that. And Dude for Him is here. My fellow CCIE written prep student. Good to have you folks. Thanks for the support, as always. Appreciate it. Yeah, this is the, what nebula is this? The Cat's Paw Nebula from Hubble. Amazing shot. And Mark Milo's here, making sure you're keeping on top of it. Yeah, man, keep me accountable, guys and gals. If I'm not here, I would expect rage, and you to track me down and find me and make sure that I'm staying on schedule. So appreciate the support, community. Today we're going to do a little lab on auto RP, and we're going to have a trivia question on SDN, which is related to evolving technologies blueprint, or the CCIE written Evolving Technologies 1.1 blueprint. So we're going to talk a little bit about that. That was my question for Duke for him today, and let's have a good discussion. Just a little bit about Azure, not a whole lot. Yeah, I've had some major issues. I posted about this on Twitter. Got some help on Twitter because, and essentially what has happened is I'm trying to build this. I want to build a bigger EVNG server in Azure and kind of share that experience with the community. This time, though, I wanted to build it using a CI/CD pipeline, which used to be called, in Azure, they had a tool that was called VSTS, Visual Studio Team Services Online. That has all been renamed, and it's rebranded and everything as Azure DevOps, which is fine. Some of the stuff is cool. And the intent was that VSTS was complicated. Their stated intent to change everything was to make it easier. And I swear, I worked, so I didn't get this lab done that I was supposed to do because I was trying to create this bigger VM, but I wanted to deploy it in the proper way, which is in Azure using automation. So I've done this before in VSTS, and I'm kind of new to it with the new DevOps interface. And man, did I struggle. I really struggled. So I got some help on Twitter on how to actually do the build. The first time I built the pipeline and ran it, it deployed my VM just fine, with the exception that the firewall rule was allowing anyone to SSH into my new Ubuntu VM, which I did not want. Obviously, I only want my IP address, so I had added that to the repo and to the parameters JSON template, and I could not get this thing to redeploy that VM. So I just deleted everything and said, fine, I'll play with that later. So anyway, I've been struggling with that. I'm not going to play with that at the moment. I'm going to go ahead and boot up my VM though. So let's see what's going on. Yeah. I'm going to do the existing one I have, which this is, of course, the D16S v3. Well, I found an E64. I found a big VM size that I'm allowed to use in my subscription. So that's what I plan to do, is build a much bigger VM just to see how it works. As if 16 vCPUs is not enough, we're going to scale it up, folks. We're going to go higher and just see how it works. And then eventually I'm going to end up with two tiers. I'm going to end up with a really big tier, like the biggest EVNG server I can make, which would be expensive by the hour, right? And then I'm going to end up with the actual reasonable cheapo server that I can use. So I'll have two servers. I actually probably have more than that. I might have 3 or 4 different servers that I can easily redeploy. Like if I screw something up, I just redeploy using Azure DevOps, and it just puts my machine, it'll put my machine back. So that's the goal. And then later we'll do like Azure Firewall deploy, and I'll actually walk through this whole, I got to get it working first. But then I'll do a DevOps repo and a CI/CD deployment of the EVNG VM server, doing that. So in the meantime, I've been working on networklessons.com. That's been going well, and I got to the point I did one other lab last night. So I finished IPPIM, I finished PIM sparse mode, I finished PIM sparse dense mode. And again, really do not have to lab these, but it doesn't take very long. And it just helps me retain some of this. I'm weak in PIM. I've been very weak historically. So the network lessons content has been great, both the reading material, the videos, and the labs is actually helping me really grasp the principles much better this time around. So yeah, I got in PIM, I'm about halfway through now. So I've done dense, sparse dense. I'm going to try to knock out auto RP and bootstrap router tonight. And my goal is hopefully we'll get to MSDP by the end of the week. This I'm very weak on. And this should be good. There's some IPv6 there, which now I get excited every time I see IPv6. I'm totally nerding out on IPv6 right now, still, which is a good thing, I hope. So we're going to do that little lab right now. The VM should already be booted up. Let's see. Actually, I didn't mean to do that. I meant to copy that URL here. Actually, let's go Chrome. Look at that, folks. Look at that. Beautiful. Hope everyone's having a good Tuesday. We got past Monday, right? So that's always good. Let's maneuver this window over here. Let's get rid of that window. And let's go full screen on this guy. We can shut that down, close that, close that. And again, the source, what I'm actually working on is a lesson from networklessons.com. So disclaimer here, I'm not showing the actual lab information on the screen. So the requirements, the explanation, any of that stuff, if you want that, definitely check out networklessons.com, not www, just networklessons.com. And many of you have already been there if you've done any kind of Google search on any kind of protocol. That's usually one of the first hits, but you can only read like part of the page unless you get a subscription. So definitely check them out. And I've already read through this lesson most of the way, and I got to the part where I wanted to lab, and I said, okay, I'm tired. And then I proceeded to play with Azure DevOps for several hours last night till very late. So anyway, let me see if I have, okay, sparse 4 routers. All right, we're going to use 4 routers again. I think I could just use this topology. Yeah, let's open it up. And we're going to revise this a little bit. Yeah, it's just 4 routers. So let's update the links here. That looks good. Let's delete this link. We can delete him. Delete him. And what we're going to do is, no, we don't want to add. We're going to delete this link. Not sure what I did there. I don't ever get this. Let's close this. You're my IPv6 hero. Oh, thanks, man. I love it, man. I just love. I am a believer now. I have definitely drank the Kool-Aid. Yeah, not sure what happened there. And I just love reading about it. I love. I'm just totally nerded out on it, man. I used to think, oh, I used to read about it on Twitter. I'd read people talking about, oh, IPv6, and I'd be like, nerd. Why they gotta be all IPv6, you know? And now I'm one of those people. I understand the hype. And I guess the biggest thing for me was to figure out that one, it's huge, and Cisco has always kind of taken the lead in terms of including IPv6 in certifications. I've heard people talk about that on the IPv6 Buzz podcast. I talked about how admirable it is that Cisco very early on has been asking certification candidates to learn it, which is all good and everything. But the thing is really kind of visionary, because the biggest thing for me is learning that how much internet traffic actually is IPv6 these days. I was shocked to learn that it's often around 20%. Only happens if you're streaming recording, lol. Yeah, the Eve stuff, I know. So router 1, 2, 3, 4. Okay, yeah, we gotta redo these links here. That could be my internet too. That's the other thing. That is one disadvantage of running a big honkin' Eve server or GNS3 or viral, whatever, pick your poison, of running that in the cloud, is you kind of need internet access to work. Most cloud providers have pretty resilient internet. Usually it's the last mile on your side. But here we go. Okay, that is the topology we want. And now let's go ahead and add our text labels. Why not? 192.168.23.0. And then this is going to be 12, right between router 1 and 2. Makes sense. This is probably 34. It is. Okay, let's fire these bad boys up. And I should probably make this, it's a small lab, probably make this smaller on the screen so I can see chat better. I hear a lot of people say, why do I have to learn it if I'm not working for a service provider? I usually tell them, if you want to pass your exams and future-proof yourself, you may want to learn it. Very true. There was a good article I posted. It really is a difficult case right now for the enterprise. I would say, yeah, it is a difficult. It's a difficult case to make in the enterprise. The most recent podcast, maybe not the most recent, one of the IPv6 Buzz podcasts was all about IPv6 in the enterprise. Like, how do you justify it? How do you sit down? One of the questions to ask, how do you sit down with the CIO or someone in the C-suite and tell them why they need to invest time and money to run IPv6? It's not an easy case to make these days. There were some good, I don't want to steal thunder from that podcast. Let's go ahead and show some love and put a link to that IPv6 Buzz podcast. And I'll see if I can find that one in particular. this was really interesting. IPv6 and DNS. Not a lot to say there because DNS works. It's not much of a pain point to switch to DNS with IPv6. You just create quadruple A records, right? Here it is. Yeah, IPv6 buzz 3. That's a tough one, folks. But you know, some valid arguments were made there. I think it's hard to convince C-suites of just about anything. That's not it. That's my VM. That won't help you. You won't be able to get to that. Let's see here. Shoot, I already closed it too. Okay, we're giving time our routers to boot up. That's really when they're the slowest, is when they're all booting up at the same time. Okay, got the link. Oh, thanks, Mark Milo. Just saw that. Appreciate that, my friend. All right, so we're going to do our base setup here. If I can find it. Wow, there is a lot. This is a long lesson. But that's okay. Oh, thank you, Marmilo. Yeah, no problem, man. Appreciates it. And I'm not sure. Oh, yeah, these routers were left. I probably should have just created a new lab. That's okay. Actually, we're going to do default interface, just 0, 1 through 3. Interface range. And we want to enable IP multicast routing, which probably is already. Yep. And we want to create over on router 1. We're going to have a loopback. IP address 1.1.1.1. IPPIM sparse mode on the loopback. Interface chat 01, IPPIM sparse mode. And it is going to be IP address 192.168.12.1. DR changed from neighbor to 12.1 on interface chat 01. Interesting. Let's do no router OSPF1, router OSPF1 network. .0. All right, and what they want us to do here is IPPIM send RP announce loopback 0. Send RP announce is all one command. And the scope is basically your TTL, like how far oh, no IPPIM auto RP. Interesting. So please unconfigure no IPPIM auto RP first. Oh, yeah, we had turned this off. I don't know if you all remember this. So when we were playing with sparse mode, remember how if you have PIM enabled, it's still going to, by default, create a star comma G for 224.0.140. And the lesson showed us a way to actually turn that default behavior off. And that is the no IPPIM auto RP. And here we're saying we want to use auto RP protocol. So the parser is saying, hey, you can't do both. You can't have your cake and eat it too. Sorry. So we're turning that back on and then do our send RP announce. Okay. So this is going to send RP announce. It's going to try to create the tunnel. Also, this is an interesting thing I learned. It kind of sunk in for me yesterday when we were talking about PIM sparse mode. And you notice how it creates the tunnels, right? There's an encapsulation tunnel on routers that are not the RP, routers that are part of the root tree. And they send and it creates a tunnel 0 and an encapsulation tunnel. And then on the rendezvous point router, it creates an encapsulation tunnel and a decapsulation tunnel. And it is literally encapsulating the traffic, at least until, for example, when a multicast sender, when you tell a multicast router to send, or a multicast host to send multicast traffic, the first PIM router it hits, it wants to know, of course, which interfaces to send it on. And actually, it's not the way it works, right? We get the join first. The host sends to the router does not forward it until it gets a join. But when the router is trying to learn the rendezvous point, it sends the first packet encapsulated. And I'll show you what what I'm referring to here. I may have mentioned this yesterday. I don't remember if I did or not, but let's pull up an example. This is from the Git repository under packet captures. And there's a multicast query. There's a PIM accept register. And this is the one I pulled up yesterday, but it just struck me, and in reading the lesson too, it dawned on me that when it's talking about encapsulation tunnel, it really is encapsulating. So let's look at the register packet. The register packet, what it really wants to be is a ping, right? So someone sent a ping to 239.0.10.20. And if we look in Wireshark, the source is 151.146.1. The destination is the multicast address. But really that ping is wrapped, as we see it's ICMP, echo, ping, right? That's a normal ping. But it's encapsulated. The first packet is encapsulated in PIM. And that's why it uses a tunnel, a logical tunnel, to represent that encapsulation. So as we can see here, inside of the encapsulation is actually the source is the same router sending down a particular interface to the next router, and it is using a PIM register, which is PIM message type 1. And it is register packet. So yeah, the ping goes out, but it's encapsulated inside, or the PIM register is actually encapsulated. No, take that back, sorry. Encapsulated protocol is ping, and the encapsulation protocol is PIM, right? So bing, that dawned on me yesterday. Then we got a register stop saying, hey, you sent that first packet over here. Actually sent the, notice the next packet is not encapsulated. Look at the source and destination on this. And this is the router downstream sending back a, notice this is not ICMP encapsulated, right? This is a register stop. Like, hey, thanks, but no thanks. So that's really more of a recap from yesterday, but I was fascinated by that. All right, so we've got this done. We've got the send RP announce. So this is router 1, I believe, saying that he is going to be an auto RP router. Yeah, so let's go to router 2. This guy's saying, okay, I'm going to be an RP. I'm going to announce. I'm going to send announce packets. R2 is going to send, he's going to be the mapping server. So he's going to do IPPIM discover, right? So we're going to say interface L0, actually show. Okay, that one's already up. The tunnel, there's a tunnel up. Can we do PIM as a section? We can. So we need to enable IPPIM RP address. We don't want that. So this is actually to contrast what we did in the last lab. In the last lab, I did, not on stream, but I did sparse dense. And we statically configured the RP routers, right? So we're undoing that now. And this time, that's the whole problem with using sparse mode and manually configured rendezvous point routers, is you can't scale that, really. That's difficult to scale. That's where auto RP comes in and BSR, right? So let's do interface L0, IPPIM sparse mode, interface J01, IPPIM sparse mode, no shut, interface J02, 23.2, IPPIM sparse mode. Uh-oh, invalid RP join. Dun dun dun. Star comma 240.140 join from 12.1 from invalid. Oh, we've still got someone trying to join to 2.2.2.2 downstream, probably on router 3. That's okay. We'll fix that. Network 2.2.2.2. Actually, we're going to do no router OSPF 1. You know, this is interesting. I could have just started a new lab, but sometimes you learn interesting things or you see interesting errors that you want to know how to interpret, right? We probably would not have seen this error otherwise. So, invalid RP join. Well, it's kind of putting a little bit of experience under our belt, right? Because how often do we come into a scenario where there isn't something sloppy that needs to be cleaned up anyway? Unless you're coming in behind a network I did, right? No, I'm just kidding. I try not to be sloppy, but now I'll tell you something. If you ever done consulting, Mark Milo, you say almost never, but if you, I imagine you're being sarcastic, maybe not. If you've done consulting, man, oh, I can tell you horror stories. Sometimes these are companies that did not want to spend really any money on networking until things were just absolutely so bad. And they had like their college nephew that built something, or someone that went to Walmart. I mean, you know, I could tell you horror stories. Loop back, 0, scope 10. So this is the RP discovery. What the lesson actually did earlier, this was not a lab, but it actually had some diagrams showing you how you could set up a rendezvous point running auto RP that was announcing, and then you had an auto RP mapping router that was configured with the discovery, and it was not connected to all the other routers. So what was happening is you were not getting, if you're not running dense mode, if you're only running sparse mode, then the other routers, if they're not on the same segment, they're not going to receive these auto RP discovery messages from the discovery routers. So that is one reason why a lot of times that auto RP is deployed with sparse dense mode. In this case, though, we're only doing sparse mode. And this is cool because a lot of times when I was reading this stuff before, those sort of details just were not sinking in like I think they needed to. Now they're, I think they're sinking in, hopefully. Okay, so we're going to do a default interface range, jazz 0, 1 to 3. You may have already done that. That's okay. Interface jazz 0, 1. IP address 192.168.3. IP PIM sparse mode. Interface jazz 0, 2. Then router let's do no router OSPF 1, router OSPF 1, network 192.168.3.0. And then this is going to be set up IP PIM auto RP listener. Oh, IP PIM auto RP, IP PIM auto RP listener. Yeah, that's the other thing. So the other option is basically to solve the problem of sparse mode, the chicken and the egg problem, as it's called sometimes. If you want to use sparse mode, but you want AutoRP routers to be automatically discovered using those addresses, right? 224.0.140. That's chicken and egg. How do you do it? Well, one way is to use sparse dense as kind of a compromise. The other way is to just allow your routers to generate these, just the AutoRP packets, even though it's in sparse mode. It will sort of act like just that group is in dense mode. But no other groups will work in dense mode, only the AutoRP groups. So that is a compromise. That's what we have configured there on router 3. Then our last router. This, by the way, is a horrible network design, right? This is like a, what we would call sort of a closed circuit, or no, open circuit. I hope you don't have any networks like this. I really do. Sort of the semi-square, yeah. I mean, there might be a few cases where you have just 2 sites, but you wouldn't want just a single connection. Anyway, we all know why that's bad. Textbook style, lol. Exactly. Textbook, what not to do, how not to configure your net, what topology design not to use. IPPIM, AutoRP, we need to turn that back on. Interface jazz 0.1. IPPIM sparse. Oh, remember we can't just do sparse. No shut, no router OSPF 1. Router OSPF 1. Remember, protocol independent multicast is dependent on, guess what? An IGP routing protocol, right? Interior gateway routing protocol. Okay. All right, so let's just check our routes here. I've got 222. It's just convergence, I think. Well, let's see. I probably still have an interface that is down. Yeah. Jazz 0.1. And no shut, yeah. We've got receive join from 12.1 for invalid 2222. Okay. IP multicast routing, loopback. Okay, everything looks good there. There we go. Okay, we've got full reachability here on our really bad network. Okay, very good. So let's go back up to some of the points of this lab here. Okay, our goal is that all routers should learn the RP address. R1 is the RP, R2 is the mapping agent. Okay, before we configure RP and mapping agent, let's take a look at the multicast routing tables. Okay, let's back up a little bit. Let's actually remove... I want to see what that displays. That does display. Okay, no IP PIMs and RP announce. Let's do a clear IPM route. Still got some junk somewhere. Invalid RP join received. Is this hard-coded in here? Show run section PIM. Yeah, let's take that out. Okay. So now, clear IPM route star. Clear IPM route star. Let's remove this announce for right now. Yeah, that doesn't look right. Oh yeah, it's send RP. Okay. So let's do a show IPM route. We'll start at router 4. What's the timer on this? Okay, incoming is null. Outgoing is J01. Okay. So it doesn't, nobody knows who's boss at all. No one knows anything. So he's just like, I've got, you know, this is a stub network basically, but he's saying, hey, you know what? Okay, 224.0.140. Outgoing, yeah, sure, I'll send it to my neighbor. I've got a PIM neighbor upstream, so I'll send it to him. This is probably going to look similar, except it'll have, for the oils, it'll have, yeah, so it's got 39 because earlier I think we had some of those auto RP messages, announcements, right? Let's clear and then do show IPM route again. Yeah, so no one knows what the heck's going on, so he's going to send out both interfaces, the star comma G for 224.0.140 and okay, that should be going away, but show IPM route. Let's clear it and issue it again. Yeah. So he's got outgoing interface list. He's got a loop back here. Do we need that loop back? Oh yeah, we're using it for the announce. Yeah, it's recommended to use loopbacks for the auto RP mapping server and announcing servers. Okay, so that's what we expect for right now. Okay, so we're going to configure R1 first. Wait a second. PIM6 invalid RP join received from 12.1. You must have that command over here. Show run section PIM. He does. Darn it. That's okay. Clear IPM route star. So we're going to go ahead and configure router 1 the way we had it before, and that is IPPIM send RP address 1.1.1.1, or no, loopback. What are our options here? Send IPPIM. Oh no, IPPIM send RP announce. And we could do the IP address of RP for the group. But we want to use, we're doing all groups, right? So we're going to say loopback 0, scope 10. Okay, so we're still not going to be in good shape yet. But let's just see what this looks like on a broken network. That's part of the value here, right? Yeah, you could configure a group list here. So by default, it's going to basically, all right, who knows what the default range that this announcement server will operate in? What is the default range? What is that network? Do you have any ideas? Let's look at it on one of our favorite sites, IP Calculator. This is the one I use, jodys.de. I love this one. All right, we know it's 224.0.0.0. Now, what is the mask for all of these IPv4 multicast reserved network range? What is the mask? Where does it start? Well, we know it starts 224.0.0.0. And where does it end? It's a /4, folks. So it goes all the way almost to 240, right? When you think about it, /4, I always remember when I'm thinking about mask bits, 128, 192, 224, 240. So, yeah, it goes right up to 240. 239, 255, 255, 254 is the max host. And the broadcast, 239, 255, 255, 255. So, a little trivia there. That is what this AutoRP server by default will operate for, unless we set a range, right? So now let's take a look at our multicast table. Okay, so I'm going to see if I can interpret this, and then I'm going to look at the lesson here. Okay, we have star, comma, 224.0.139. This is the RP announce group. Very important to remember. The difference between .39 and .40, right? .39 is RP announce. .40 is RP discover or mapping. So incoming interface would be null, of course. And outgoing interface list right now is null. That's interesting. It is stopped. Well, because why? Because it has no groups, it has no IGMP hosts, right? I'm assuming that's why. That's why it doesn't have to be. Oh, because it's star, comma. That's right. Yeah, it's star, comma. So now we have S, comma, G, because we know of an RP server on the network, and that is ourselves, which is on loopback 0. So that's why we have an expiry timer. running on this S, G. Yeah, if the timer's running here, it's not going to be running here generally, right? So S, G is running, incoming interface is loopback 0. Outgoing is null because we have no why do we have none? It doesn't show any outgoing interfaces, but R1 is now flooding its RP announcement packets on its interfaces. Okay. Maybe this doesn't congeal until we actually get a mapping agent running. Star, comma, 2240140. Incoming interface null. Outgoing is L0. What are the flags here? This is DCL. Interesting. Dense, connected. And L is local. Yeah. This is PT. That means pruned. And shortest path tree bit set. Yeah, I don't know. Sometimes I get confused when I look at these reserved group addresses. And it tends to make more sense once we have some listeners on the network interpreting. These are just weird ones, right? Okay, so now we're going to go ahead and put our mapping agent in place. IPPIM send RP discovery. Loopback, same kind of I think I tried to just do L0 and it didn't like it. Let me see. No, that works. Okay. Never mind. I lied. Okay, so now we should be not so broken, right? And let's look at these packets. Uh, 0, 2, right? Yeah. Show interface tunnel 0. Oh, look at that. That's pretty cool. So when you do a show interface tunnel, it'll actually tell you, hey, this is a PIM register tunnel. It uses the same bandwidth as a standard tunnel interface. Tunnel protocol is PIM, and the transport is IPv4. In other words, we are transporting IPv4 over PIM, which is what we saw in the packet capture before, right? And my Wireshark did not start. Hold on. Jazz02. Oh, I have to do this differently, don't I? In Community Edition. I don't remember. Huh. It's trying to launch the window, but it can't. That's weird. I wonder why that is. Let's do a little quick. All right, I'm going to come back to that, folks. I don't want to take up everyone's time here. I have some of these already, I think. Not sure. Maybe not. But here's what one looks like. So it says RP mapping. Whoa, there it is, really big. Notice here, folks, IP, the source is the loopback, the destination, of course, is 220.140. Of course, this is the auto RP mapping agent. Source, destination. I find it interesting how it's interpreting, how Wireshark or CloudShark is interpreting these fields. GeoIP France, ASN number 3215. Yeah, I think you might be misinterpreting those bits there, folks. UDP, this I do not know. UDP 496. I'm a little skeptical of that. Let's look on auto RP packet capture. Let's find some other packet captures on this. There we go, packetlife.net. Oh, you can look at it, CloudShark here too. Does this also come from France? It does say that. That can't be right. All right, let's look at good old Wireshark. Good old reliable Wireshark. Oh, faithful. I thought I downloaded it. There we go. RP announcement, RP mapping. So let's look at the mapping. Yeah, see, this doesn't say that it comes from France. Where are those bits? Oh, that was because maybe because it was 02, 02, 02, 02. I don't know. Oh, here we go. Yeah, so it thought the source 2.2.2.2 was somewhere in France. And that may very well be. That 2 network might be assigned to an ASN in France. As a matter of fact, who is... Actually, it's easier. I'm on BSD. I got the power of whois in my hands here. Yeah, France Telecom. So CloudShark was misinterpreting. I mean, I guess in a real production network, you probably would not want to use this. As a loopback, you would want to use RFC 1918 space, but I can see why it would do that. Interesting. That's funny. But yeah, here is the mapping agent, of course, destination 2240140, and the announcement is 0139. One group. Okay. And we've got our show commands, right? Show IPPIM RP hash. Not familiar with that. Oh, the group. Yeah, I don't know what a RP hash is. Is that authentication? Well, that's taking a while to run. PIM v2 hash value mask 0000. Okay. I'm not going to concern myself too much with that at the moment. But we can do show IP PIM RP mapping. Show learned RPs in use. Show only elected auto RPs. Okay, that's taking a while to run as well. There we go. PIM group to RP mappings. This system is an RP. Group 224004. There it is. So this is one way to ask a router what the multicast range is. Info source 222 elected via auto RP. Cool stuff. 22400/4. 22400/4. We're going to try to remember that. 22400/4. All right, moving right along. Let's look at router 2. Show IP PIM RP mapping. Actually, I think I need a space. This is the thing, like when to use a space, when to use a hyphen. The bane of my existence right now. To hyphen or not to hyphen? To space or not to space? That is a question that we are asked frequently throughout our engineering lives. PIM group to RP mappings. This system is an RP mapping agent through loopback 0. Very nice. So have you noticed here too an RP 1.1.1.1 for version 2 and version 1? It is backwards compatible. Okay, now let's look at router 3. Now, should router 3 know about the RP server? It should, because we have that command running, right? The auto RP listener, which is global mode. Darn it, we need to take that out. Show IP PIM RP mapping. And we're going to run the same thing over here. Okay, I'm expecting router 4 to be ignorant of what is going on. Okay, so router 3 knows about the RP, and the source is 2.2.2.2, right? So that's the mapping server, and this is our RP. Clear IPM route star. How does he know about this? I'll bet you I know how. Okay, all these interfaces are shut except that one. And there is a tunnel interface. That's fine. This should now be on a timer. Yeah, how does router 4 know? I didn't think show run section PIM. Yeah, show run interface chat 01. IP PIM sparse mode. All right, let's do this. Let's shut. Clear IP mroute star. It still knows about that. I wonder if there's a way to clear this as well. Expires 2 minutes. Okay, so it's counting down. Clear IP PIM RP. Oh, you can. Sweet. Okay, so I got nothing. I got show IP mroute star. Remember, we don't have IP PIM auto RP listener configured. So let's bring the interface back up now. I'm going to do a debug IP PIM. Our OSPF is coming up. Show IP route. Okay, yeah, we've learned the loopbacks through OSPF. Show IP mroute. How does it know about 1.1.1.1? I don't understand. Okay. Let's look at router. Let's look at our topology. So I'm only connected to router 3. That is it. Router 3 oh, so you know what? Auto RP listener is going to work for all interfaces on router 3. That's why. Let's take that off. That's why. And we'll go back over here. Clear IP PIM RP mapping. Clear IP mroute star. Initiating register encapsulation tunnel deletion 4. Thank you, debug. All right, so he's going to know about it because R2 is going to be sending these on its interfaces, but R3 will not be sending it to R4 now. That's what it was. Okay. That's why. All right, so all we have to do is turn it on here. IP PIM auto RP listener. It only has to be on the upstream router for R4 to get it. Okay, that's why. Yeah, I got ahead of myself on this lab here. There we go. Yep. I missed seeing your map. What is the RP? Oh, sorry. RP is router 1. The RP, yeah, it's the router 1. So, yeah, for some reason I was thinking that the auto RP-PIM listener command had to be on the router itself, but it's only has to be at least on an upstream router in the segment. And then what will happen is R3, acting as a listener, is going to treat 39 and 40 as essentially dense mode, and it's going to flood it out of its outgoing interfaces. So that's how R4 was getting it. I took it off of R3 and we're good. We're able to break it like we wanted to, but candidate RPs are routers that advertise themselves. They send packets to 224.0.139. Mapping agents are routers that listen to 224.0.139 with a list of all possible RPs. They elect an RP and advertise this to the rest of the world by using 224.0.140. Problem with auto RP is some routers might be unable to receive packets from the mapping agent. And some mapping agents might not be unable to hear all RPs. Yeah, that's what we sort of demonstrated in the lab there, right? Okay, let's take a look at BSR. Yeah, that's a good sized little lab. I probably won't do BSR, bootstrap router, on stream. I've actually never labbed anything like that, so I'm not sure how far I'll get on that one. So anyway, we'll stop here on this lab. That was a good one for auto RP. And let's move on now to another topic, which is our trivia question of the day. There we go. So in the area of software-defined networking, let's find this on the blueprint, folks. I liked how that turned out yesterday, so it's good from time to time to just go back and check the blueprint, make sure that we're on track, especially now that it has changed with the evolving technologies. Oh, that's right. I did this yesterday. This is in the Git repo now. Let's see here, SDN. Okay, network programmability, SDN. Describe architectural and operational considerations for a programmable network. Data models and structures. Device programmability. Controller-based network design. This is where this falls into play. Controller-based network design, policy-driven configuration, northbound, outbound, northbound, southbound APIs. So we start talking about SDN controllers. What does come to mind, first of all, are the Cisco ACI, of course, and NSX. So what I did is I shared with Dude for him this link. Now, before, this was all I had. Like, I didn't have really anything. I would have an item in the blueprint and that was it. There was no official guide for evolving technologies, right? And this is the new 1.1. But, as many of you may know, I looked recently, and on Cisco's site, they now have like reference videos. They have a lot of materials you can actually look at as a reference. I didn't have these before, so I just Googled a bunch of stuff. And look at all these VODs and training videos. So there's a learning matrix now, which I've already downloaded, but I'm curious what this says about SDN. So it has some references here, right? Places you can go to learn. Now, I may have already watched these because when I was looking for SDN stuff, look at this. This is good stuff, man. I did not have this before. Virtual Pub Build an Agile Programmable Data Center, SDN recorded seminars, API controller, EM deployment, program for network engineers, designing and implementing Cisco network programmability. Breakout sessions. Yeah, look at all these breakout sessions from Cisco Live. I need to go back and actually watch these. Anyway, this was my research. I shared this with Dude for Him. I have out on Git I put my notes out there on Git, so and this again, this is just really ACI and NSX. But actually, let's open up. I have it cloned locally, right? So I'll open my notes and we'll go over this. This is really, SDN comparisons is not a good name. This is really like SDN controllers comparisons. So based on the research I found, and these were the best articles I found. Well, I linked this Gardner. I don't know if you can actually... I was having difficulty finding something to really kind of compare these two. You can find information about Cisco ACI, you can find information about NSX, but how do you really compare them one to the other, right? And what I found is, of course, Cisco ACI ships with physical workload support. Essentially, you can control physical devices, right? They don't have to be virtual machines. They don't have to be virtual switches. They can be physical routers, right? Physical switches. That's not the case with VMware NSX. You cannot just out of the box use NSX on physical devices. Now there are ways to address those architectural considerations with NSX, but that's one difference I could find. Network hardware agnostic Cisco ACI, that is not the case, of course. So you have to have certain Cisco routers and switches to support ACI, right? You got to have Nexus 9K. You can't have Nexus 5K, right? At least not that I'm aware of. VMware NSX will work with quite a variety of different physical or, different vendors, not just, they have a lot broader support, of course, in terms of what the host can interface with, what type of networking devices that the host can interface with. A lot of different vendors support NSX, right? You cannot, that I'm aware of, support ACI on a Juniper switch, for example. Hypervisor agnostic, one advantage of Cisco ACI, right? You're not locked into VMware. You can run, for example, KVM, and I'm pretty sure, let's see, what are some of the, don't quote me on that. I'm not sure of all the hypervisors that it supports. Of course, it's part of Cisco UCS. But yeah, VMware NSX, no. You run it on VMware, obviously. That may change too. That may not always be the case, but at least I believe that's how it is now. How do you scale out the solution? With Cisco ACI, you have to add leaf and spine members, right? And NSX, if you need to scale it out, you have to add hosts. Additional hosts are required to run the NSX instances. With Cisco ACI, integrated external L2, L3, that's talking about like connecting to Internet Edge. Again, we're kind of grasping at straws a little bit here, but yes, you can do Internet Edge at layer 2 and layer 3 with Cisco ACI out of the box. NSX, you have to add some specific virtual instances to support that. Obviously, Cisco ACI in general is preferred by network teams. Now, that is coming from Cisco, I think, or no, that's coming from Gartner. And then NSX is generally preferred by what are traditional virtualization teams, right? So, anyway, that's all I could find so far, dude, for him. I don't know if that's complete, probably not, but more work to be done there. This was a great link I saw today, getting onto some other meat chunks. This was shared by Banner MOTD. There's been some discussion in, I think, the service provider section about DMVPN or routing switching, like, which is better on DMVPN, OSPF or EIGRP? Well, there's some more reading on that. And then one of the Discord members also posted this Twitter link. This is cool just because I've got a lot of background in F5. And I think I've read about this before in one of their like upgrade docs about this. I have read about this before, but Sagar Devil shared this, and this is about how you can help avoid issue with Mac stability whenever you do a failover. So this Mac masquerading feature is there. So good stuff, guys and gals. Thanks for joining tonight. I think this is going to wrap it up. It's been a great stream. It's been fun. And we learned some stuff, good stuff. 69 days ago. Let's keep jamming. Thank you for all the support, folks. You can follow me on Instagram, Twitter, YouTube, etc. Of course, here on Twitch. And appreciate all the support of the community and all the great discussions in Discord. If you have not joined the Discord, folks, that's where it's at. That's where it's all happening. That's where you link with other streamers and a lot of folks are studying for, some are studying for CCI security, some for data center, some for routing and switching, of course, service provider, wide range of folks there that you can connect with. There's CCNAs too, people studying for CCNAs, CCENT, CCNP. We've got it all. So thanks for hanging out, folks. It's been good on this Tuesday night. We shall see you back here, same time, same place, here in the Lance Tamer stream, tomorrow night, 7 p.m. Eastern Time. Sending good bits. Have a good night.